Hello everyone, and welcome to my session on creating analysis services data models more easily and quickly. My name is Kai Unkrot. I'm a program manager in the analysis services team. And one of my focus areas since May this year is the data modeling experience in SSDT, among other things. This is a level 300 session, so please expect the content to be fairly technical. But even if you don't consider yourself the ultimate die-hard BI pro, you should be able to follow my demos and explanations quite nicely. Only if you're entirely new to analysis services, you might get disappointed because I'm not going to go much into the basics of data modeling. My expectations would be that you already have experience creating data models. Otherwise, why would you come to a level 300 session? Right, so the other aspect that is worth noting is that this is a session packed with demos. I will show you some source code. I will show you some techniques that you can use to go beyond certain limitations that exist today in SSDT, where you sometimes wished you could do bulk operations, for example, eliminate tedious tasks. I will show you some techniques that are now possible with analysis services in 2016. And I hope you'll get some ideas and maybe some tips and tricks to make your life as a BI professional easier when it comes to building tabular data models. One question already came up before this session. Is this going to cover multidimensional or tabular? It is going to cover only tabular data modeling, and specifically it's going to cover data modeling at the new SQL Server 2016 compatibility level, which we call the 1200 compat level. Another point, as there are quite a few demos, we're running on a tight schedule. If you have questions during the session, please feel free to ask at any time. But if you could hold on to them until the end of the session or come to me afterwards, that would be appreciated. So what are we going to cover here today? First, we'll go real quick through a review of the enhancements that Analysis Services brings to you with SQL Server 2016. And then we'll go into the fun part where I'll show you how you can take advantage of these new enhancements to automate tedious tasks and get to a solution delivery a lot quicker than if you just use SSDT or other tools to do it by hand. So the SQL Server analysis and enhancements revolve really around all the major components that we have in the stack. But before we go into that, maybe I should explain the motivation for me to create this session. It was back in April when I was still busy with a project for reporting services, actually, where I needed a data model. And at the time, I thought it was a good idea to just go into the AdventureWorks tutorial. Is any one of you familiar with the AdventureWorks tutorial in Books Online? It's actually a really nice tutorial. It goes through quite a nice explanation of some of the data modeling concepts. And so I thought it would be a great idea to just take this data model. I needed one to work with reporting services against it. Little did I know that I was in for a treat when I started working with that data model. Has any of you completed this this tutorial? If you haven't, and if you try to approach it, let me show you, there's a very interesting section in it. This is the tutorial. And the lesson I'm talking about is this one, lesson 3. It is about renaming columns. And when you approach this lesson, as the title suggests, you're going to rename some columns. Now, this lesson is going to trick you into thinking that you're going to be done with this lesson in 20 minutes, but I would suggest you bring a bit more time with you because you're going to rename some columns, and not just one or two, but you're going to rename a few columns. There are columns, and you're supposed to rename them. And you're renaming columns, and more columns, and more columns, and more columns. And just when you can't take it anymore, there's another table where you need to rename columns, and some more columns. You think you're done? Who are we kidding? More columns, and more columns. I think I need half an hour just to read all these column names. So here we go. Oh, almost done. No, not really. More columns. Are we done yet? Not really. It's continuing. There are more. Finally, yeah, are we there? Nope, not yet, not yet, please. Oh, thank goodness. Now what made it worse for me in April was that we actually had a bug in SSTT where I couldn't even copy these column names out. Because when you copy them, they take a little bit of HTML characters, and in SSTT we had a bug that would choke on these HTML characters that you don't see. So I had to type this all in manually. It took me 4 hours to complete this lesson. At the time I thought, maybe we should have an award, I survive lesson 3 or something. But there was something that came out of it, and that was, I thought, man, I'm just renaming this for this tutorial. I actually had a talk with the author, Owen, who wrote this tutorial, and he said, Kai, there is no way I can help you get through this faster. It's a recommended best practice that you rename these columns, and I couldn't just skip through it because all the measures and relationships later depend on these column names, right? So, especially when I wanted to use it in a way that a reader from my blog article could later follow all my explanations verbatim, I had to complete this all. So we had a discussion, can we make this simpler? And this is just a simple data model with 7 tables. It's not really that tremendous, right? And I was sitting there and I'm thinking, man, this is something you guys probably do on a quite regular basis, renaming columns, and not just a few. A production model probably has 20, sometimes 50 tables, and you're renaming columns like this. And of course, when you work in SSTT, there is no bulk operation. In fact, you go click on the column, either go to the properties window or click on there, click rename, and then you finally get into it. And I thought, man, there must be an easier way to do this. And there is. It's just not in the tool directly. But that was one of the motivations I had for creating the session, to show you how to survive these moments where you're facing these daunting tasks, where you spend hours just doing repetitive, tedious things that you just need to get done. And then when I looked into this, I thought, wow, renaming columns is just one of those tasks, right? When you approach a data model, there are maybe 20% in that data model that are truly unique to it. All the other stuff is repetitive across data models. Right? Take time intelligence, for example. Time intelligence is a great example that you probably find in a large number of data models, and when you look at the measures, the DAX formulas, these expressions, they are not truly unique. You're comparing a sales number over the previous year's quarter. Yeah, well, great. That's not something that's, earth-shattering, unique to a particular data model. In fact, are you familiar with this daxpattern.com site? Have you seen that one? If you don't know that, remember that, because that can be a real time saver for you. In fact, I'm going to go a little bit into that. There's Marco Russo and Alberto and some other of the community. They create these websites for us. Another very useful one is daxformatter.com. I like that. You have a DAX expression, you want to have it really nicely formatted, post it into their web form, and they give you back a really nicely formatted DAX expression. But on DAX patterns, they have really these common business problems that they just solved for us. Like time intelligence, they have a whole bunch of expressions that you just take and can put into your data model, and you're done. Well, at least with that part. And what I'm going to show you is how to do that in a blink of an eye. Another problem that DAX pattern, for example, solves, that I'm going to demo to you, is you have a table with customers. Now you want to know who are your new customers, who are your recurring customers. It's not a unique problem to a particular business that applies to perhaps every one of us. And when you take these patterns and you templatize them and then you put them into a data model, then you get to a solution much, much quicker. And that is what I'm trying to show you today. I'm not going to show you very clean code. I'm just showing you the key parts of the code that need to be done, and the gotchas, the little things that sometimes need to be considered when you do it. But my hope is that you will find that the techniques that I'm going to show you, that you can use them even with extremely little programming knowledge yourself. All right, back to the slide. Another thing worth mentioning is the slide deck that I created has a whole lot of slides in it. I'm not going to show all the slides. I'm just going to show you, review real quick the enhancements in Analysis Service, and then we go into code. The slides are there because the deck will be available for download later as a reference for some of the main points. But let's talk about the enhancements in Analysis Services first. This architecture diagram basically shows you all there is on a high level in Analysis Services, and it's a great diagram to highlight some of the improvements that we've made. On the multidimensional side, it's not that much. In SQL Server 2016, the code base is very mature. We approach it very carefully. We really weigh and consider what we should do. We've done some roll-up optimizations for Oracle, for example. We have a database consistency checker on that side too. But that's pretty much it for multidimensional. On the tabular side, however, we have tremendous improvements with 2016. For example, we have this entirely new storage mode for the metadata, which we call the 1200 compatibility level. It took us 4 years to land this improvement, and SQL Server 2016 was the first version where we were able to ship it. So in the storage engine, when we look at the stack, is any of you already running SQL Server 2016 Analysis Services? Have you noticed performance improvements for existing models that you had previously on the new server? So you're just building from scratch new? Some customers see performance improvements that even our developers can't explain. For example, there is a customer, large beer manufacturer in Denmark. They have seen improvements for certain workloads where a query that took 2.5 minutes on SQL Server 2014 Analysis Services all of a sudden took 3 seconds. Yeah, nobody really knows what all kind of a perfect storm came there together. But we have some improvements where you naturally can see, yeah, that has to be resulting in better performance. For example, the strict evaluation of the if-switch statements. When you write an if statement or a switch statement with multiple clauses in 2014 and 2012, the Analysis Services engine would evaluate all the possible paths that you have. So if you have if expression true, false, we would go down both paths, true and false, and just after we arrived, we would throw the one away that we didn't need. Obviously, that takes a lot of computing power and time. And now in 2016, we finally were able to put an optimization in that we look at this first and then just go down the path that really matters. One thing. Or grouping sets. If we have a query that queries the same, let's say, dimension with multiple granularities, let's say a date on month and day and week, then we just ask for the lowest granularity and figure out the rest ourselves. That saves us storage engine queries. Those things end in a significant performance improvement, and that's even for old data models. So if you have data models on SQL Server 2014, they will benefit from these types of improvements just by putting them, without migrating anything of these data models, just by putting them on SQL Server 2016. I used to have demos where I showed this. I had a Power BI report, and I would run this against SQL 2014 and SQL 2016, and the performance was 50% faster. I'm not showing it here because it's too high level. We want to go deep into some aspects for time reasons. So VertiPack itself also has seen improvements. I mentioned it, the 1200 compatibility level that we have is one of the noteworthy improvements that we have. These optimized metadata operations you will enjoy every time you work with SSDT when you do data modeling operations. If you work with an 1103 compat level data model, which is the data model from SQL 2014, you will probably notice when you have a complex model with lots of measures, lots of tables, lots of relationships, that when you rename a column or when you perform operations, it gets really sluggish. The operations sometimes take 5 seconds, sometimes even longer than that. It's not really a positive user experience. The reason for that was that inside the analysis services engine, a tabular model was still represented from the metadata point of view as a multidimensional database. Yeah, we just bent over backwards internally to make it look like multidimensional, even though the concepts were completely different. And out of that came a lot of performance, regressions, if you will. Now with 1200, we have a true tabular metadata stack. If you're familiar with SQL Server, the relational engine, think of sys tables. We have now some equivalent of sys tables in the engine. So when you have a table, we have an entry in a tables table. And if you have columns, we have columns in a columns table that reference that of the table. And if you rename a column, well, then we rename a column in the columns table, and we're done. And that results in a snappier user experience in SSDT. So when you work with a 1200 compatibility level data model in SSDT, you will, I'm very confident, you will experience a better user experience than when you work with 1103, where we have this older metadata stack. The other thing that comes out of this 1200 compat level is that we have a whole new scripting language. And you will see that in this session, because the scripting part is one of the things that you can use to go in whenever it's tedious to work in the user interface. You could go to the scripting level and just do it there. Of course, if you make a mistake there, like you forget a comma somewhere, then it's based on JSON, then this JSON document is no longer valid, and then you get into trouble. But we also have an entirely new tabular object model. In SQL 14, we had this AMO object model, which was still, in terms of fact tables and dimensions, it wasn't really tabular. Now we actually have a tabular object model where when you work with a tabular database, you work with tables, and you work with columns, and you work with relationships and measures. And it's very intuitive, as you will see, because that's the code that I'm going to demonstrate. We also have completely rewritten the directory stack in 2016. I'm not going to go much into directory here in this session. Just let me point out that with directory in 2014, you couldn't even support Excel clients because they use MDX, and MDX clients were not supported. And the only data source that was supported was SQL Server in the backend anyway, so it wasn't really a useful stack then. Now we support both DAX clients like Power BI Desktop, as well as MDX clients like Excel or other products like Tableau. And we support Teradata, Oracle, and SQL Server in the backend. We completely rewrote the directory stack, also for performance. If the backend has the performance level you want, let's say you have a highly optimized SQL Server database with column store and so forth, if the performance of that data store is sufficient, then a directory is worth an evaluation because you don't pump that much data around anymore, and you don't need the processing. Now, some of the improvements I already mentioned that we're going to also stand on heavily here in this session are about the tabular editing experience. We have something completely new that didn't exist before, which is called Formula Fix-Up, which I think is one of the most useful things for the daily work of the BI professional. Have you ever worked with a 2014 model that was nice and done and you renamed the column? And then you had to fix that all up manually yourself? Well, this is Formula Fix-Up now. With 1200, you don't have to do that anymore. When you rename a column, as you would perhaps expect, we are also renaming all the references. We rename it in the measures, we rename it in the relationships, the model remains intact. We have new DAX formulas that are useful. We have bidirectional cross-filtering. So when you have three tables in a many-to-many relationship, for example, and like a dimension fact table approach, if you will, and they both have a relationship that points towards this fact table, then you cannot really filter down the third table from the first table because the filter context doesn't flow over these relationships. But with bidirectional cross-filtering, that works now, so you can actually have many-to-many relationships within a data model. You can save incomplete measures. That was also not possible before. You had a measure that wasn't really complete yet, and you wanted to go home to come back the next day. You couldn't save the data model. Now we allow you to let it be saved. But in all fairness, you can't process that data model unless it is actually consistent. So. And we have our display folder support, we have localization support. Now, some of you may be familiar with these unsupported features that exist in 11.03, like localizations. And Bits Helper rings a bell. Bits Helper is a tool that the community wrote that allows you to use these unsupported features. And we didn't carry those features over into 1200, but we have equivalent features now in 1200 models that are actually supported. Yes. So that was really my theoretical explanations on what's new in analysis services and good reasons to use analysis services with SQL Server 2016. And the other good reason is if you want to take any of the things that follow now into your daily work, then you need to be on SQL Server 2016. None of what I'm going to show you is going to work with 2014 or the 11.03 compatibility level. And because I mentioned to you that AdventureWorks tutorial, so let's start with that AdventureWorks tutorial. Here is the result of the AdventureWorks tutorial. Here's that fancy data model with all the columns renamed. I'll show you the diagram view with all the pretty column names. And for me, as a first exercise to show you how to do these operations real quick, let's revert the changes. Let's undo 4 hours of hard labor and revert these columns to their original names. Let me show you real quick what the JSON script looks like of this data model. The reason I'm going into the scripting view is to show you the properties that a column has inside the data model, and when we use that programmatically, we can use certain properties on these columns to find the original name and then revert real quick. So let me go. Here's, for example, my tables collection, my data sources, my relationships, my perspectives, my roles that I may have. This is what a 1200 compatibility level data model looks like at the script level. And let's take just one of these tables, like the customer table. And here we see, for example, in that table, the column definitions and the partitions and the annotations that the tool sometimes puts in. And here in the partitions, you see where this data actually comes from. It comes from a SQL Server database. And if we look at the columns, you can see that the column has a name, which is the renamed user-friendly name, and it also has a source column name. That is the actual name from the underlying data source. And if I wanted to revert all these nice changes in the data model to go back to the source column name, what I would have to do is go through all the tables and all the columns, look at what the source column name is, and overwrite the name of the column, and then I have undone all my changes. So let's do that. Let's write a little tool with the new fancy tabular object model that gives us exactly this behavior. Oh, my computer switched into maintenance mode here just a moment. Let's stop this. We need the performance for ourselves. I'm just going to create a console application. It's the simplest of simplest applications. Let's go ahead with that. So the first thing we are going to do is we're going to reference the libraries that we need to perform programmatic operations against analysis services, which is, in the tabular object model case, the analysis services management objects, also known as AMO. AMO, this library, this redist, is available in the SQL Server 2016 feature pack. You can download it and distribute it with your applications. And here, for my purposes, I just need this directly in my data model. So here, under the references, I'm going to just add these libraries that I need. Because I did that before, Visual Studio remembers these. What is this? Let me just select them, and then I'll zoom in. Can you Can you see these guys here? There are three. The normal analysis services server, that's the general AMO library that you need when you program against multidimensional or tabular objects at the higher level, where it doesn't matter which one you're really using. The next one is the tabular library, which you need specifically when you want to go against the 1200 data model. And the third one is just a JSON thing, which I need because I'm actually not working against an analysis services database that is loaded on an AS server. What I'm going to do is I'm going to program the model.bim file that is in my analysis services project. So let's first add these three files into the project and put some namespace declarations in here that I need. For the first one is the IO namespace because I'm going to read out a BIM file, not just a text file, as you've seen as a JSON text file. The second one is the general analysis services library, which I'm aliasing with SSAS just so that the code becomes more readable. And the third one is this new and fancy TOM library, the tabular object model. Tabular. There. So this is all I need to get started with working with the object model. So the first thing we need to do now is to define the path to our BIM file. By the way, is this readable? Not really. Let me try some, increase the font size for you. Font. Let's try 14. Better? Okay. The BIM file path is not that dramatic, right? I have this under my projects here. Here's my tabular model, and there's my model.bim. This is the file that defines the entire data model in my analysis services tabular project. I'm going to hijack this, if you will. And what I need to do with that path is I need to read out the metadata. And that's easily done with the file object. Read all text. And then this BIM file path. Great. And now I need to deserialize this metadata into a TOM database object, and then we're ready to party on this. So it's basically just this TOM database, MyDB equals TOM JSON serializer dot deserialized database. And that's the metadata that I need here. Okay, now I have a TOM database. Without a server, I can party on that just from the client libraries. And then I will do some work here in a moment. And when I'm done, we'll come to the work in a moment. Then I'm going to serialize what I've done back into that model BIM file, which is basically just a write all text back into the BIM file and deserialize that database. Serialize, sorry. Nah, JSON serializer. Serialize that database back into that BIM file. And the next time I open this up in SSTT, I will have all the changes that I've done, with which is the part that we're going to implement in a moment. Let me just wrap this up a little bit here with just a right line. That we're done. Come on. Oh, and a read line so that the window doesn't just close on me. Okay. So now the dramatic part is, what do we need to do to get to our columns? Well, that's very trivial, really, at the end of the day. We're going through all the tables. For each tom.table in MongoDB, and it has a model, and that model has tables. Look at that. And then for each table, we're going through all the columns. For each tom.column in table.table columns. There. Now we can say column.name is whatever. There's just one little thing here that now we need to keep in mind, and that is a table can have multiple types of columns. You can have calculated columns, and you can have columns that come from source tables, for example. And we're specifically interested in the tables that come from source tables, because those are the only ones that have these source column properties. So we need to say here, if the column is actually a data column, this guy, okay? So that we can safely cast this column to what we need. Then the name should be the source column. Right? Come on. Yeah. That's it. Is that hard? Now, would I run this? No. Why? The bad news is if you run this code, it'll break your data model entirely. Anybody can think of the reason why? Oh, it's because as I mentioned before, for 2014 data models, I'm going to rename all the columns in the data model, and I do it on the client side, and on the client side there's no formula fix-up. So all my relationships and all my measures, of course, are somehow, somewhere using columns from these tables, and they use the names that exist today. And if I just go in and change the column names like I demonstrate here, then the result of this would be that the data model is broken, and I would have to fix all the relationships, all the measures, and so forth myself. And that kind of defeats the purpose, because then at the end of the day, you would have to create that data model from scratch again. And that is not really, in this particular scenario, a good approach. I still wanted to show it to you, and we're going to the right way to do it in a moment, because many of the things remain from this. Also, let's say if you didn't have any relationships or any measures yet, then this is a perfectly fine approach. It's just about not breaking the references within the data model. The references within the data model, right? So later, let's say I add a new table, I don't need to go into this more advanced scenario that I'm going to show you in a moment. If I just want to rename something that has no other implications or add something, go ahead, do that, that's fine. And that runs a lot faster than what I'm going to show you now. When I want to rename columns like I need to do right now, and I need to ensure that the data model remains consistent, I need the help of an analysis services solver, specifically a 2016 analysis services solver. So I actually need to deserialize this data model, load it on an AS server, and then request the column changes from that server, and that server will change all the dependencies along with it. And then once I have done that, then I can serialize that result back into my model BIM file, and then the model will be consistent. So let's do that. First, we need a solver. And I'm using the using statement because that keeps it nice and clean. I don't have to worry too much about cleaning that up myself. Great. The next I need to do is I need to connect to that solver. And that's just a connection string. As always, data source equals server name. And the server here is called server SQL AS / SQL 2016. I'm not doing any exception handling here. This is just my little personal tool to get my job done quickly. So now I'm connected to this AS server, and I have deserialized that data model already. Now I just need to add this data model to my server. And that's server.databases.add mydb. And then I need to update, I need to send the changes. I'm working with a client-side object model where I basically just add this database as a reference to the server object. And now I need to cause an update so that the data model is actually loaded on that server. And that is, I just need to specify these update options. And I need to expand the full model so that this works. And at this point, I actually have loaded this entire data model on this AS server that I specified. Now here's a little thing that can cause your code to fail. If I run this the first time, it works perfectly fine. But if I run it a second time, it will fail because this model has a name and an ID. And you can only have one database on the server with the same name and the same ID. But I don't want to change the name and the ID of my model, so I'm going to retain the original names, and then I'm going to ask the server to give me unique names so that I can for sure load this data model. So basically what I'm saying up here is string org name is mydb.name, and string org ID is mydb.id. And now I can say mydb.name is AS server.databases.get me a new name. And try to use the original name if you can. And if that name already exists, this on the server, this function will append numbers to the name. So it will be, data model 1, 2, 3, 4, 5 if I already have data models on that server. And the same goes with the ID. And this time we say, give me a new ID. Oh, there's a little typo in here. Org ID, come on. Now it should work. And when I'm done with my work, down here, I need to restore the names before I serialize out this data model to my BIM file so that I don't change anything too much in that BIM file. And the way I do this is I'm going to create an offline copy of that database in my client side. So I will have a new database. mydb.clone. There. And now I'm free to assign my original name and ID back to that offline database. It's a bit, coding here at the moment, but that really, you only do this once and it's always the same. These techniques, when we go into the other scenarios that I'm going to introduce in a moment, this will always be the same. If you change something that exists, this is the technique you use. You load this, you remember the original names, you load it on the server, you do what you have to do on the server, and then you create an offline copy, you restore the original values, you serialize that offline DB out instead of the other DB, and then you throw the other DB away that you temporarily loaded, which is just a simple mydb.drop. Done. Now, I haven't really changed yet how we rename the columns, and that's really the interesting part of the exercise. Here, this should not be done that way. Instead, I'm going to remember that name in here, and now for the column itself, I'm going to say column.requestRename. I'm going to use that column name. So instead of me assigning a new name to that column, I'm sending that new name as a request to the server, and I'm saying, server, please rename that column for me. And then I just need to go into my database model and say, save the changes. Because I need to, when I do formula fix-up, I need to do this for each column individually. It's a little slow, but it works. And it saves me all this tedious work that I otherwise have to do. So let's see, when we run this code, and that's all. When we run this, it'll take about a minute to complete, because it goes through all the tables. And then, indeed, 4 hours of hard work have been eliminated. And I'm looking at the data model as it were originally when I imported the data. And then I can actually show you a technique how to get past this tutorial more efficiently. But my computer is running a little slow here. This should be a bit faster. This is the demo effect, I guess. This should actually be done by now already. Okay, while this is running, let's move a little bit ahead. Now I have a data model where I have the original columns. Well, this is not really a scenario that makes a lot of sense, right? You usually don't go from beautiful column names back to ugly column names in your data source. But it was kind of a step for me to demonstrate to you this technique of how I can program against the model.bim file. Now I'm actually at the stage with my data model where I actually can approach the real production scenario where I have a number of tables where I actually need to rename the columns into something that is user-friendly. Now, of course, I can't just take the source column name now. Now I need to really go to this tutorial. This is seriously slow right now. Oh, we're done. Okay. Then let's see the effects of it real quick. And what you're going to, that's another gotcha here, what you're going to see most likely is an error. You will see something about that there is a column mismatch of some sorts. In the September release of SSDT, we introduced a feature called Integrated Workspace Mode. Are you familiar with this feature yet? Integrated Workspace Mode eliminates the need for a workspace server with SSDT, where you used to have to specify an explicit analysis services instance. You don't have to do that anymore. SSDT now runs its own instance, but as part of it, as a performance optimization, you don't see it because I have script view open, that's always good. Yeah. As part of this optimization, we keep the setting here as unload from memory for the workspace database retention, which means we keep the database on this disk. And now I change the model.bim file, so the model.bim file is out of sync with that data model that we initially cached. So when I try to load this in the designer, you will get an error because things don't add up anymore. And the way you solve this problem simply is by deleting that cached database. This is expected right now. Let me show it to you. It talks about some is-key property here that isn't really, unique anymore. That's because I renamed this column, but the cached model still has the old column, and it's trying to load on top of that, and it just can't figure it out. The way you do this is just, you go in here. Let me close the solution. That's important. You go into this project. In the bin directory, you find a data folder, and you just delete that one. You have to throw the old cached model away. And if you do that, then you're good. Now the model.bim file is the only thing that describes the data model again, and SSDT will load that up nicely. Just in case, you ever encounter this. Yeah, now I should be able to load this, and you will see all the tables with the ugly column names. Now let's go and actually rename these columns into something that is user-friendly. The way I do this is basically I'm going to take these tables from this web page simply with Power Query into an Excel spreadsheet. Right, I go here into data query. Where's my from other server, from web. I already prepared this, so I'm just going to show it to you. That's relatively straightforward. Power Query will give me all the tables, so I don't need to copy them. Right, here's my table, for example, for these various tables, and I get, when I load them, I get these tables into the Excel spreadsheet. I already did this here once, and I named these tables accordingly to what the actual table in the data model is. I saved this workbook out, and now in my code, as I demonstrated it already to you, let me open the other project here. Where's my rename? Let me open that project. Fast lesson 3, here's my solution for that. It's exactly the same code as before. I'm going to load my data model on the server, just that I'm not going to iterate anymore through the columns themselves and grab some source columns. I'm going through this worksheet now. And I'm just looking at all the tables, which are named objects, which are these list objects. I'm finding the table in the table model, in the data model for it, and then I'm going to just pick the right names and assign them to the right columns, and my job is done in a lot less time if I run this. And the formula fix-up will kick in for me again and will ensure that the data model remains consistent. And now I bring down my work effort from 4 hours to 2 minutes. That was the first scenario that might make sense for you. If you always import the same ugly tables into your data models, just remember the column name somewhere, and then just write yourself a little code that does it for you, and you're out of that tedious task of clicking around and typing in column names and so forth. Now, the next scenario revolves around date tables. I'm just talking ahead because this program takes a while here to run. When you look at a data model, it's very common that it has a date table. And because SQL Server 2014 did not really have good support for date tables, it is very common that the source has the date table. Now with SQL Server 2016, we changed that. We have new DAX statements, specifically calendar auto, which generates a date column based on the dates it finds in the data model. It takes the earliest date and the last date that it finds, and it creates a date column for you with consecutive dates all out. It can't be easier to start a date table. The second thing is that you can specify with a calendar function the date range yourself. Now, in my solution here, let's go into this tabular model again. It's going to complain again because I forgot to delete the data folder. Now, in my adventure work solution, skip that one. I need to close the project. Do it again. Now let's open it. In my adventure work solution, what I would like to do is not just replace this date table that exists. Here now my columns are all back. I would like to actually also add more columns to it that represent a moon calendar. Because in my AdventureWorks business, it's really important to analyze sales based on moon phases. Now this table doesn't have this yet. So what I'm going to do is I have another solution where I built this date table once, and I copy this date table out and keep reusing it. So basically, here in the projects, I have my date table, here my calendar. This is what the JSON of this date table looks like. It has the exact same columns that the other table has, but it also has, at the end, some calculations to figure out what the moon phases are. And then I have a new hierarchy. The idea is that I'm going to take this JSON, I'm going to swap the old date table out, but I'm going to keep using the column names and the table name that the original table had. So I'm not going to touch any of the table relationships. So I can just delete that table, add the new table, and then look at the model, and it will have just the same referential pieces in it. All the measures will work and continue to work, and then I can very quickly analyze whether this sales data actually has anything to do with moon phases, whether customers buy more products or not. Now, there's a different scenario from the programming perspective for it, and that is that my moon calendar actually uses a JSON snippet instead of an Excel table. So I'm going to deserialize not just a full data model, I'm going to deserialize a little fragment, an artifact from another solution that I built before. And that looks like this. Where is it? Do you see my date table somewhere here? Here, replace date table. So in this solution, same thing, I load the data, the metadata, but I also have this calculated table file that I keep loading, and the way I'm going to do this is I'm actually going to deserialize an object, and it's a table. And because I'm not changing any columns or any of the references that are in the data model, this time I don't need to load it to an AS server. This time it stays nice and simple. All I'm going to do is I load the BIM file, I throw the old date table away, I take my new table and put it in, and I'm done. And that should run a lot faster. Done. Now I have a totally calculated column, date table that is no longer dependent on any data source. I don't have any issues anymore whether the data is clean, whether the dates are all consecutive. I know that this is all just fine because this is my own calculated table, and on top of it, I actually have the solution that I need to analyze my sales data based on the parameters that matter to me. Again, I should really concentrate more. Now, this date table replacement is just one scenario where this might come in handy. Are you familiar with parameter tables? Right, a parameter table is a table that has no relationship to any other table in the model. It just serves as in a BI solution like in Excel, you put it on a slicer so that the user can pick up a value, and you use that value as input into your DAX expressions. The example that I have, which is a very common one, is when you want to scale numbers, right? You have $1 million and you want to not say it's 1 million numbers, you just want to say, hey, divide this by 1 million and then it's 1 million, you know, that kind of thing. Here's, for example, now my date table with the moon calendar. Let me show you this real quick. And then with the parameter tables, all I need is just another one of those JSON constructs. However, here's my moon calendar now. However, in this case, I need to actually have a calculated table that gives me also the values along with the columns that I want. And this is here, for example, the case. This is a date table that just makes up its own data. Think of this when you paste the table into a data model with 1200. This is the kind of construct that SSTT creates automatically for you on the fly. So if I import this table, I will get a table with how many rows? 1, 2, 3, 4, 5, 6, 7 rows with these values. And now I just need to create that measure on the sales table so that I can take advantage of this. And this is this solution here. And it's the same principle as with the date table. I have this JSON snippet. I deserialize that particular object out here, and I add it to my tables collection. And then I'm creating this additional measure on the sales table where I basically say, if the user has picked just one value from the slicer, then divide the total sales with that sales factor. That's a common scenario for you, how you can actually utilize these parameter tables. And to show you this in action, let me run this real quick. And this is the prelude to the next demo where we're going to take actual full DAX patterns and throw them into the data model. So now I have a data model here. Let me just delete the data folder. where I have a parameter table added and the measure at the same time. Come on. And because I threw that temporary database away, I need to reprocess the data model to show it to you in action. Let's do that real quick. The data model is not that large. And then you can see that parameter table in action. So there might be one type of parameter table that you may often use, or there might be multiple. It makes no difference. This approach is always the same. If you want to reuse those tables without having to recreate everything in SSTT, just save it out in a separate JSON snippet, and then use a little Tom script to put the table into your data model, along with the measure it needs. So here we'll do an analyze in Excel real quick. Let's put the internet, come on, my scaled measure on values with the dates, like so, for example. Or let's take the moon calendar, why not? Let's see if we actually did have some changes based on the moon phase. Shouldn't. No, doesn't. Oh, hold on. Well, not really in AdventureWorks. People are not really sleepwalking too much. But I can also now insert my parameter table as a slicer. Here. Right, there's my scale, and now I can say, give me that in millions, and it calculates them out, so I have 7 million. That's how a parameter table works. Okay. Now, I've mentioned to you that DAX pattern side, so now we're having a data model where I just want to not just create a table and one measure, I want to create a whole bunch of measures at once, let's say, 10, 20, 100, I don't know. I've prepared that, but I want to also reuse it. There's another element to it. Here, for example, here are my time intelligence functions that I want to use. And you can see here I have replaced the actual column names with some kind of a tag in that JSON. So the idea is I have these patterns where the measures are always the same, the DAX expressions are the same. What changes perhaps per data model is the name of the tables where I want to throw them in, and maybe the name of the columns. And in this solution, I didn't do it as a console application this time. It's a Windows Forms application. But the principle is effectively the same. So ultimately, I'm going to get into this method here, and I'm looking at this pattern. I'm going to use a regex to find all these tags that I have, which in my own convention have this ampersand, blah, ampersand, which is what I manually did. I took Marco's formulas, put them into a data model, copied the JSON snippets out into my own text file, and then went in and replaced all the actual column names and table names with these little tags, with these ampersands. And my code now finds these ampersand tags and gives them to me in a data grid, so that I can actually then specify the actual values that I want. And then when I click Save, really what I do is in this construct, I'm splitting up these references, and I'm going to replace these tags with the actual names that I selected. Now I have valid JSON back. Then I can deserialize that into an object, which I add to the data model, and my job is done. And this is what this is going to look like when you run it. So here I'm going to select my BIM file real fancy ways. I'm going to throw these time intelligence functions against this BIM file. Here's my JSON construct. I'm going to add it to the internet sales table, and I need to have the sales amount column, which I just go through the data model to find all the resources that are in it, and the sales amount is down here somewhere. Where is it? There. Then my target table name again, well, it's just a tag. I didn't really clean that up. So that's again internet sales. My date table name is date. Here, the calendar year column from the date table would be this, calendar year date, and then the date key column would be date date. There. And these are all the tags that I have in this large JSON file that I templatized. I can replace that and click Save. And now, effectively, I added all these measures that were in this template file to my business solution. And I should have now an internet sales table with a significantly larger number of measures than before. And all my time intelligence has been taken care of. While this is loading the data model, I also have a file for the customers, which is not as involved. Let's open this in Notepad, for example, so that we don't have to wait here too long. So this here is, for example, for my customers. You count the customers, and I replaced again everything with these tags. These are just 3 measures that I put in here. So here's my data model now with the internet sales table with all these measures that I added, these starting here down to here are new measures that I created. And they're all fully functional because I referenced the right columns because I've specified them. Let me show you this real quick with the customer column. Because that's easier to analyze and easier to visualize, actually. So I'm just going to run this again. And also to demonstrate that this application can work with any type of templatized the BIM file. Looking at the wrong thing. Here's the customers. This goes into the customers table. The date key column would be date date. The date table is date. The sales table is internet sales. And my customer key is customer ID. Here. Let's save this. Done. Yay. And let's load up the data model again. And as you notice, this time I don't have to delete any cached files because I simply add measures that don't affect that. And now I can actually analyze how many new customers I have in this business, how many recurring customers I have. And I didn't have to write the DAX myself because I just took that from DAX patterns. And I can apply that to any of the data models that I have where it's applicable. And I can save myself some time once I have just implemented that solution for once. So here's let's analyze this in Excel. Here are my measures. And let's see on the date what it looks like. And you can see in this AdventureWorks data set, apparently this business has rather few recurring customers. Most of them are new customers, so I guess AdventureWorks is selling most of the time only once to a customer. Maybe they are not very happy customers. They buy once and never return. Could be some interesting business insights for them. But the point really was, it's the same principle all the time. You load the model BIM file into a TOM database object. You load the snippet from wherever you have it, whether it's a clean JSON file, which you can deserialize directly into an object, or whether it's something that you've pre-processed to get a JSON construct out of it, and then you just add this to the data model and you serialize it back into the model BIM file, and then you have it in the job done, and you don't need to really redo all these things in SSDT all the time and re-clicking and redoing it. Another approach that you could take is, for example, when you look at the data model, let's go back in here. When in diagram view, it's better visible. There. You can see that this date table has multiple relationships, right? There is an active relationship and there are two inactive relationships. If you look at the internet sales table, you can see that it actually has multiple date keys. There's an order key and there's a shipped key and there's a due date, basically. So the same date table, depending on which relationship you're using, gives you the numbers based on different timelines. Right? For example, you could say, do you count sales based on when it was ordered or when it was shipped? These kinds of things. There can only be one relationship active at a time, which you can see always in the diagram view as a solid line. The others that are dotted are inactive relationships, which you need to reference in a measure explicitly using the use relationship function. Are you familiar with that function? Basically, if you have, let's say, a calculate statement that takes a filter expression, one of the filter expressions that you would specify is use relationship internet sales ship date, comma, date key, so that analysis services knows now you don't want to go against the order date, you want to against the ship date. Now, this approach is perfectly fine and valid for some scenarios. It complicates your measures. If you, for example, have a bunch of time intelligence measures in your data model and you want to go with this construct, you would have to recreate all these measures again and specify the ship date as a separate use relationship path. Now you can do that also, of course, with Tom. I'm going to show you the code how to do that. An alternative approach is you're going to split the date table. So instead of one date table, you have three. You call the one order date, the other one ship date, and the other one due date. And then you don't have to do all that dance with the measures because every one of those individual tables has only one active relationship then. And the measures will immediately work depending on what date table the user uses in the business solution. There are pros and cons to both of these approaches. The obvious pro for the multiple date table approach is that you don't have to duplicate all these measures, right? The con is sometimes in the analysis, when you have a pivot table, it's hard to compare numbers side by side because you would have to drag multiple date tables around, and that's not that easy to put them all on rows or all on columns. So it depends. Sometimes it might be the one approach, sometimes it might be the other approach, and sometimes it might be both approaches. But whatever it is, you can use this technique of serializing and deserializing this into a TOM object to make your life easier because it's very easy to copy that date table. Just go into the data model, serialize it, get the date object, the table object that you have, clone it, give it a different name, and add it back into the data model, and you have two data objects. And then you just have to actually fix the relationship, or you can do that even programmatically as well, because relationships is just another programmable object right there. And the other approach, I already mentioned it, is you say, my business users just want this one date table. They really don't want two. So let's, just clone all these measures instead. There is nothing in SSDT today that allows you to do that yet. We'll see when we get to that, right? It would be nice to just right-click on this. And here, basically, we're going through this data model, and I'm going through the measures. And I'm looking at measures that can take a filter expression if they start with calculate or total quarter to date in this data model. And then I'm just going to take the expression. And I'm going to throw the ending bracket away. And then I'm going to replace that with a statement, comma, use relationship. Come on here. Use relationship on the ship date. And then if I add this, of course, I need to add a unique name to it. So I'm going to put that as the same measure name with this note that it is now shipped. And because I create a lot of measures that way, possibly I also assign a display folder for it so that the user interface would look nicer for that. And that way you can solve the problem too for the case where you have situations where you want to keep the date table with multiple inactive and one active relationship intact. We have 5 minutes left. I just wanted to show you some of the solutions that the community has built around the tabular object model. This is, in particular, I would like to show you 2 solutions that a consultant in Denmark has created. The first one is actually quite a wild one. This is a Power BI, a Power Query workbook. I have the path to it here at the bottom, if you're interested in that blog article. The scenario, the problem that he's solving is that when you have an 1103 data model with all these unsupported features in it, then you can't just migrate it with a simple right click to a 1200 model, because these features, even though a corresponding feature now exists in 1200, they are different from each other. So you actually need to have some kind of a script that goes through the old model, finds all these resources that existed in the old model, and recreates them with the tabular object model in the new model. And this Power Query workbook that he created actually does that. It goes into the old model and reads out all the metadata and creates a PowerShell script on the fly that it outputs. And all you then have to do is just copy that and run that in PowerShell. And it's basically the same what I showed you with C#. The reason I just chose C# is because it's more intuitive, and with IntelliSense it demos quicker. I don't have to search so much around. In a PowerShell window it's a bit trickier. But you can totally program these objects in PowerShell if that's your preference, or you want to have scripts that you run somewhere else. And this is a great example of a PowerShell script generator, and it's available to you today. And the other solution that he has is this tabular editor that he's creating. Now, Daniel is apparently not very happy with SSDT today. If you read his blog article, he's kind of ranting a bit about it, so that's okay. I don't blame him. We certainly have enough room for improvements in SSDT. And he's saying, hey, what you're doing in SSDT is maybe good enough, maybe not, but for me it doesn't work. I'm building my own tool, and that's what he's doing. And he's using exactly these principles that I showed you here today, going against the model.bim file or a tabular database. It makes no difference. And for example, for localizations, I believe he has a better story than we have, where you export basically into a JSON file, then you need to localize it and so forth. By the way, I don't think you need to take pictures. You can download this presentation from Ignite, and this is in the presentation deck directly. So this is really 2 advanced scenarios where customers are using Tom to solve problems they have. We have other customers that build data models completely on the fly. They go into a SQL Server database, discover all the tables and all the relationships, which you can do in a SQL database, and they create corresponding resources directly in their data models. And if the schema of that database changes, they generate a new data model on the fly and send it out and process it, and boom, you have a new data model that works perfectly fine again. All those scenarios are now possible with relatively little effort because of that tabular object model that we now created. Aligns very nicely one-on-one with a tabular space where you have tables, columns, measures, relationships. And that's pretty much the end of this session. Thank you very much for your attention. I hope you got some ideas out of it.